Okay, so we're going to start by factoring a trinomial here. So a trinomial is 3 terms. And so we have 3 terms here made up in the most basic form of ax squared plus bx plus c. And in the problems before we've been doing factoring where there was no equal sign. So at the end, you would just factor and you would have some fully factored form, which we'll get to in this point, but we're going to take it a step further in this problem. So the first thing I want you to do is when we factor this trinomial is we're going to take the a value, 6, and we're going to multiply it by the c value. So the first step is a times c, which in this case is 6 times 4, which is 24. And then over here on the side, I'm going to just list all the factors of 24. So 1 and 24, negative 1 and negative 24. 2 and 12, negative 2 and negative 12. 3 and 8, negative 3 and negative 8. 4 and 6, negative 4, negative 6. And so once we have all those factors, those are all the possible things I might use in this equation. And then after I have all this listed, we will just add those two factors together. So this would be 25, negative 25. 14, negative 14. 11, negative 11. 10, negative 10. And when we have that, okay, we are then going to look for which of these factors matches B when I add them together. And if you do that, you see that 3 and 8, when I add 3 and 8 together, I get 11. So those two are going to be the factors I use. Okay? And what that allows me to do is we know how to factor by grouping. So if we can get to 4 terms, we're in a good spot. So what we can now do is if we keep the first term the same, 6x squared, we are then allowed to split up this middle term, the 11x, into those two factors we just found, my 3x plus 8x. Because if I add 3x plus 8x, I get back to my 11x that we just came from. So there's nothing weird that went on here. These two numbers just came from the 11x. And if I added them together, I could go backwards. Well, now we have 4 terms and we can factor by grouping. If we look at the first term together, right, these two together, I could common factor of 3x. So 3x, 2x, plus 1. Right? Because if I divide 6x squared by 3x, you get 2x. If I divide 3x by 3x, I get 1. And out of the second term, I can factor out a 4. 4, 2x, plus 1. The key here, again, is that you make sure that what's inside the parentheses is the same. Here it is. They're both 2x plus 1. And if you get what is inside the parentheses being the same, you can then factor out each one of those. Right? So there's a 2x plus 1 in each one, and that would leave me with just what is outside the parentheses. So 3x plus 4 equals 0. And now, this is considered fully factored form. So if you ever have a question where it doesn't have an equal sign and it just asks you to fully factor, that would be considered fully factored form, where now it's just a parentheses times another parentheses, and it's all good. Right? There's nothing else I could factor out. In this question, we now are asked to solve, though, because it has an equal sign. Well, just like we did when we were trying to solve intercept form of a parabola, we just set each factor equal to 0. So when 2x plus 1 is equal to 0, the whole equation would be equal to 0. Same thing when 3x plus 4 is equal to 0. The whole equation would be equal to 0. So when you solve here, this would be negative 1/2. And in this one, x would be negative 4/3. So these are my two solutions that would cause this equation to be equal to 0. What we've also called those would be the x-intercepts if I graph this equation. And so the bottom part here, from here to here, or actually from here to the end, this is the part we add when we are looking to solve. Right? The part above is what you do when you factor to get the fully factored form, and then here you would get to solve.